In this second example, we're going to look at class problem 2, where a baseball player has an on-base percentage of .400 or 400. In a game when the player is up to bat 5 times, we want to know what is the probability that they will get on base at least twice. So just to clarify what it means to have an on-base percentage of .400 or .400, just means that when the player gets up to bat, the percentage chance of them getting on base is 400 out of 1,000, which is 40% or 4 out of 10. So that's how often, based on past at-bats, this player has gotten on base. So that's how that on-base percentage is determined. Now, in order to create a probability experiment for this, we can't use things like coins or dice because we need the probability here to be 40% as opposed to being 50-50. So that's why the coins won't work for this particular simulation. But let's look first at why it would be appropriate to use a simulation. So first of all, it would be hard to find a player who has an exact on-base percentage of 400. They vary quite a bit. And then to have a game where the player is up to bat 5 times and you would have to do that 50 times in order to have 50 trials, it would be very difficult and time consuming and probably nearly impossible to create those conditions. The other option is to find 50 different players that all have an on-base percentage of 400 and have them go up to bat 5 times in a game. But again, that's very, very difficult to find that or to set that up. So using a simulation in this situation is much more time effective than to actually carry out the experiment. So in order to design a probability experiment, a few different options here. If I go back to my random.org, I can use the playing cards here if I want to. I have to draw one card from my deck, and because I need a 40% chance of the player getting on base and a 60% chance of them not getting on base, I can use the cards from ace to 10, which gives me 10 options, and then I define ace 2, 3, and 4 as being on base, and then 5 through 10 being not on base. And I need to only draw one card at a time, which would be one at bat. The reason I can't draw all 5 cards is because in this particular app, the cards are not replaced every time. So that would not create a correct simulation, because once a card is drawn out, then the probability of getting on base would change after that. So I only need to draw one card at a time. And so it would take a little bit longer doing this because I have to do, in the first at bat, they didn't get on base because it's a 6, where I said that ace through 4 was getting on base. So didn't get on base, did get on base, didn't get on base, didn't get on base, and didn't get on base. So out of those 5 times, this player only got on base 1 time, which means that the event didn't happen, because if you remember, the actual event is find the probability that they will get on base at least twice. So 2 or more times in those 5 at-bats. So in this case, I would put a tally under A prime, or that the event didn't happen. So this will be a little bit time consuming, not too bad, but you have to do 5 cards for one trial and then do 5 cards again for the next trial and so on. So it's possible to use the playing cards to do that. The other option in random.org is to just use a random number generator. So I can use an integer generator where I want to generate 5 random integers to represent my 5 at-bats. And I can do between 1 and 10, or I can do 1 in 1,000 or 1 in 100 if I want to. I just have to make sure I define what the numbers represent, which numbers are on base and which numbers are not on base. So let's do between 1 and 1,000, and I'll say that 1 to 400 means that they're on base, and then 401 up to 1,000 would be that they're not on base. So when I get those numbers, this represents my 5 at-bats. So not on base, not on base, not, not. So this player in this game didn't get on base in any of the 5 at-bats. So that would mean that the event did not happen. And then if I repeat it, then I'm on base, not on base, not on base. Sorry, other way around. On base, not on base, on base, not on base, not on base. So that means that 2 out of the 5 times I got on base, so that means that my event did happen. And so for the next part where you have to show a specific outcome, for the event, and for the complement of the event, this is one that I could screenshot as an example of the event happened in this case. So that's how we can use a random number generator to do a simulation, and that is useful when you have a problem where it's not a nice like 50-50 chance of something happening, or say a 1 in 6 if you were using a dice. That's a nice example. With a dice you can do evens and odds if it's 50-50, so you have lots of options if it's a 50-50 situation, but if it's not, then you can use random number generators to represent those probabilities. And so I would do 50 trials of my experiment, identify my two outcomes, one where the event happened and one where it didn't, and then I would calculate the empirical probability based on the results of my 50 trials, and then express it as a fraction, a decimal, and a percent. So the next step for you is to create your own problem. So you're going to create a problem that you think you can use a simulation to do trials to determine the empirical probability. So what I would like you to do is, once you have your problem, post it in the discussion area and wait for me to give you some feedback on it. And then once I give you feedback, then go ahead and do your 50 trials and determine the probability for your particular situation. Use these class problems as examples, so use them as kind of guides, but I want you guys to try to create something that is going to be unique to you, that will be, you know, a little bit different. So you could use like a similar kind of scenario, but maybe use a different sport and use a different kind of stat, or maybe you know, use some kind of other situation, like, I don't know, if you have 5 people in your family, what is the probability that they were all born on a Monday or something like that, you know? So a problem where you can use a simulation to try to recreate that situation happening to determine the experimental probability. So if you're having trouble, come and see me or send me an email, and send me your problem in the discussion when you have it ready to go. Good luck.